All right, guys, so here is our next video that we're going to watch tonight to get us ready for our next class on proofs. We're going to be looking at a new rule that's something we've discussed before about triangle correspondence. So it's something we've seen in the past. We're going to extend it into proofs today. So what I want you guys to do for a minute is to pause your video when I tell you to, and I want you to think about what you can prove about these two triangles. So notice what I have marked in. Think about everything you can prove about triangle ABC and triangle DEF. So go ahead and pause now and just take a minute or two to think about what else you can tell me. Okay. So hopefully you really paused and you didn't just pretend if you didn't do it now. But what I see here is that these two triangles have an AAS congruency. So we know these two triangles have to be congruent because they have this AAS relationship. So did you come up with anything else? So what we've talked about in past units is that if now these two triangles are congruent, these are identical twins. Triangle ABC is perfectly exactly congruent to triangle DEF because of this AAS congruency. So what this tells me now is that, for example, I know that angle B would also have to be congruent to angle E. I know side AC would have to be congruent to side DF, right? So if these two triangles are exactly congruent to each other, it means that all their matching parts have to be congruent. I would also be able to prove that side BC is congruent to side EF. So notice the new thing we're able to do now. If I can prove the triangles are congruent, so I'm sorry, I should have mentioned this is nowhere in your notes. But I know that if two triangles are proven congruent, then all their corresponding parts must also be congruent. So it's a really huge idea, and it's actually nothing new, nothing that we haven't really discussed before, but it's going to really help us in the proofs we're going to do next class. So if the two triangles are proven to be congruent, and that's exactly what we spent last class doing, then we know all of their corresponding parts must also be congruent. And if you go back to page 2 of your note packet, so hopefully you have your orange note packet in front of you, we filled this out last time, and I told you we were going to hold off and wait on this next part, but down at the bottom here, it says, in order to prove a pair of corresponding sides or angles is congruent, we first must prove the triangles themselves are congruent. So in order to prove a pair of corresponding sides or angles is congruent, we must first prove the triangles themselves are congruent. And we do that by the usual methods we've been doing, SSS or SAS or ASA. So there's an abbreviation for this. So if you're doing a proof, the last step, what we're going to look at in a minute, I'm going to link a couple of videos. I'm going to kind of splice them together. So if it sounds different or if it looks different, it's because I used an old video and just added it onto this one. But the abbreviation we can use here is CPCTC. So corresponding parts of congruent triangles are congruent. Okay, so if you need to pause and finish writing that down, please do. I'm going to zoom ahead once you're done writing that down to page 9. So please jump up to page 9 once you're done writing that down. And I'm going to really just super quickly set you up with number 14, and then I'm going to, like I said, splice that other video in there for you. Actually, you know what? I think I'm going to do number 16. Well, whatever, maybe 17. I'm not sure what video I'm going to add in, but I'm going to talk about number 14 real quick. Notice the difference here. So for number 14, I'm not asking you to prove the triangles are congruent. I'm asking you to prove angle B is congruent to angle D. So I don't know that that's true yet, but I'm asking you to prove that's true. So in order to do that, the first thing we have to do is, just like we've been doing, I'm first going to have us prove that triangle ADC is congruent to triangle, let's see if I name this carefully, I'm going to match it up to triangle CBA. So the first thing we're going to do is prove triangle ADC is congruent to triangle CBD. And we're going to do that just like we always do. However many steps it takes to get there, we're going to make this whole proof. And then at the end of this proof, we're going to prove those triangles are congruent. Once the triangles are congruent, then I can prove that angle B is congruent to angle D because of that new rule we just talked about. Corresponding parts of congruent triangles are congruent. So if the triangles are congruent, I can then extend that and prove that their corresponding parts are congruent. Okay, so I'm gonna end this portion of the video. I want you to keep watching. I'm gonna edit in an old video that I had and try to watch it through. And I might put 1 or 2 proofs on there. I'm not sure how many I'll put on there, but watch that video through. It's going to use this new rule, and so hopefully next class you can come in ready to go. All right. So good job. I'll see you next time. Keep watching, please, and yeah, I'll see you in class. Next up, number 17. Just to warn you, this is a 7-step proof. So what I did on my copy was turn my paper sideways and do my statement and reason this way. It'll give you a little more room. I can't do that on the computer, so I'll just work top down, but you may want to turn your paper sideways and make your statement and reason column that way. All right, I'll pause while you get that done, mark in your givens, and be ready to go. There are our givens. The unfortunate thing about this proof is that we can't mark anything in yet. We have some important information. We have a perpendicular line, and careful here, we have an angle bisector. But there's nothing we can mark in just yet. We have to actually lay out the steps in our proof. So before we get into that, like I always say, let's look at what we're trying to prove first. All right, you're not going to jump into a paper in English class and just start writing. You want to think about what your goal is, what you're trying to do. So, proof. Segment AC is congruent to segment BC. That's what we're trying to prove, that those two segments are congruent. So just like we've been talking about, we know we can look backwards 1 step. In order to prove that those segments are congruent, what we can do, or what we need to do, is prove triangle ACD is congruent to triangle BCD. So forget this. Forget what this says. What we're really trying to do is prove triangle ACD is congruent to triangle BCD. All right, so make it simpler on yourself. Try to make the easiest way possible. So if we prove that these two triangles are congruent, the rest of it will just fall into place. All right, so once we prove the triangles are congruent, then we can use our CPCTC. All right, so what I'm going to do, I'm just going to start at the top. Let's use that given first. So we have our perpendicular line symbol. What do we do with perpendicular lines? We know they make right angles. So since CD is perpendicular to AB, we know for a fact angle 3 and angle 4 are right angles. The reason is perpendicular lines make right angles. Now you can probably pause right now. Let's see if that line will come down a little bit. You can probably tell what the next step is without even waiting for me while I fix this line up. Oh well. So whenever we have right angles, the next step is to always say that those right angles are congruent. So next we have angle 3 is congruent to angle 4 because all right angles are congruent. There is one piece of information. We have now proven that those two angles are congruent. All right, we have 2 more pieces to go before we prove our triangles are congruent. So let's move on down the list. Let's use our second given. So our second given, CD bisects angle ACB. CD bisects angle ACB. So angle ACB, again, follow with your pen, ACB, that's this vertex angle right up top. So what does an angle bisector do? It cuts an angle in half. So we know angle 1 must be congruent to angle 2 because an angle bisector cuts an angle in half. There's another step, one more down. So we have two pieces. We know 3 and 4 right angles, all right angles are congruent, and we know angle 1 is congruent to angle 2 because an angle bisector cuts an angle in half. That's all the givens we have. We've used them both. We did a good job with that. Now we're kind of on our own. It doesn't look like we have any substitution. It doesn't look like we have vertical angles, but it does look like these two triangles physically share a side. Physically sharing a side, there's your reflexive property. CD is congruent to CD because of the reflexive property. All right, hopefully you guys saw that. Here's where you need to be careful. I think I talked about this last class. These triangles, this kind of proof you see all the time, these two triangles back to back. Sometimes D will be the midpoint. You know, a lot of the time it'll be the midpoint in the given. This one does not have that in the given. So if in your proof here you were thinking about saying AD was congruent to BD because D is the midpoint, it looks like you're correct, but remember, you cannot use that unless it was given to you that D was the midpoint. So we actually had enough information without that. All right, so now we're done. We have our third piece. Step 6. We now can prove that triangle ACD is congruent to triangle BCD because of angle, side, angle. And that was our whole goal. We knew once we proved the triangles were congruent, that has to come first. But once you prove the triangles themselves are congruent, then you can prove without a doubt that all their matching parts are congruent, which tells us that segment AC is congruent to segment BC because corresponding parts of congruent triangles are congruent. All right, so triangles come first, then you can prove anything you want about all their corresponding parts. So there you go.